Hello, what's up everybody? In this video we are going to look at the third problem from today's Codeforces round 667 div 3. It is called yet another array restoration. So we have a secret array of which we only know about two elements, that are x and y. We need to restore the whole array, but we know few facts about our array, and those are all the elements of the array are distinct and greater than 0, and we have been given two elements only, which are x and y, where the value of y is greater than x, and the difference between all the adjacent elements in our array is same, that is a2 minus a1 is equal to a3 minus a2, and so on. It can be proven that such an array always exists. Okay, and we need to find out one such possible arrangement in which the maximum value of our array is minimized, that is the last value of our list is the minimum possible. Okay, here as we can see, the range of n, x and y are pretty less, so it will not affect our solution. Let's see what we can do here. Yep. So we know about two elements, those are x and y, and total number of elements we are having is n. So we might place few elements in between x and y, that is, yep, and the number of elements we can place in between x and y ranges from 0 to n minus 2, because if we had placed n minus 1 elements in between x and y, then n minus 1 plus 2 turns out to be greater than n, and we cannot have more than n elements in a array. So maximum elements we can put is n minus 2 and minimum is 0. This is the first thing which we need to observe. And the second thing here is, suppose we have this x and y and we are placing three elements in between x and y, and let's say the difference between these two is L1, then this would also be L1, this as well, and this as well, because it is mentioned in the question that if you sort the array in increasing order, the difference between all the adjacent consecutive elements would be equal. If you see here, it also means L1 should be a divisor of y minus x, that is the total gap between y and x. And suppose if we had placed only two elements in between x and y, and let's say this is the difference here is L2, then it also means then L2 should also be a divisor of y minus x. So we can use this observation or info to get your answer. Now the first thing which we would be doing is finding out all the factors of y minus x, and then now we need to maximize the last element of our list. Now as we have been given the y, we cannot have our answer which is less than y, because we cannot change y. So our answer that is not answered, our last element of our list, if we have sorted it in increasing order, would be greater than equal to y. It cannot be less than y. Okay, so first what we will be doing, we will try to place as much elements as we can on the left side of y, and if we are still left with few elements, then only we will move to the right of y and start placing elements at the right side of y. So first of all, we will place elements in between x and y, and if we are still left with few elements, then we will try to place them here. And also our elements cannot be lesser than 0, so we will try to place them here. And if we are still even then left with few elements, then only we will place them on the right side of y. Then we will need to print out such possible list. Okay, for that I'm finding out first of all what I'm doing, I'm finding out all the factors of y minus x. Then for each of the factors, let's say f1, I'm trying to fill the space between y and x, because this space must be filled. We cannot have elements lying in half of this space and then leave this space remaining. For example, let's say we have x and y, and the values of x and y is 7 and 15, and we place two elements at 8, 9. It means the difference is 1 between the adjacent elements. And if we left this space as vacant, or we are having this vacant space, it means the difference between these two elements is 6, but this is not allowed. So one thing we should make sure is we need to fill the whole gap between x and y such that the difference between all the adjacent elements is equal. So the first thing we would be doing, we will fill up the space between x and y, and in a way such that the difference between adjacent elements is equal. If we are left with few elements which are still not placed, then we will try to place them on the left of x, as we do not want to go further than y. We want to minimize the maximum element present in our list. We will go to the left side of x. We are left with few elements. We cannot go to the left side of 0. And if even after that we are left with few elements, then only we will move to the right. Now we will be placing the elements between x and y at a difference d, where d would be a factor of y minus x. We will try all possible combinations of our factors, and if we are not able to fill in the gap between x and y, then we cannot use that value as our difference between adjacent elements, as I have explained it here. And if we are able to fill the middle gap completely such that the difference property is satisfied, then we move to the left side. Then after that, if we are still left with the element, then we only will move to the right side. You can find out the answer for all the factors and take the list which is having the minimum last value, or if you observe or notice something out it, the answer would be the list which is having the factor as difference, the smallest factor of y minus x as the difference, in which we are able to fill in the in between gap of x and y. So yes, you can think about it. Now let's see the code now. So yes, I've taken the input. Now I've found all the factors of y minus x. This is the find factor function, where I'm pushing the factors of y minus x into my fact vector. This is the global vector which I have initialized. After finding out the vectors, after finding out the factors, I'm sorting them. It is not really needed, but I'm just doing it as the value of n is very small. It is 50. Now I'm going through all the factors of y minus x. I'm checking whether, if by using this factor as the difference, I'm able to place or fill in the gap between y minus x and place all the remaining elements, then I'm printing my list. For list, I'm using dq. Why I'm using the dq? Because I'll be explaining the reason here. Now this is the check function which I have called for each of the factors right here. Now this is the difference which I'm currently checking, that is the difference between adjacent elements I'm allowed to have. I see the number of middle terms I would be placing if the difference between adjacent elements is this div, and that can be found out using this equation. You can think about it, y minus x divided by div minus, let me give you one example as well. Suppose we have x as 20 and y as 50, and if we are using div is equal to 6, then the number of middle elements we can put is 50 minus 20 divided by 6 minus 1, which comes out to be 5 if I'm not wrong. No, which it comes out to be 4. So if you try to think about it, yeah, it would be 26, 32, 38 and 44. These would be the 4 locations where we would be putting our elements. Yeah, it comes out to be 4. And if I see the middle number of middle terms which we are placing between y and x plus 2 is greater than n, where these 2 represents x and y is greater than n, then we are returning false, as this is not possible. It is not possible to use this div as the difference between adjacent elements. And if it is not so, then I'm sure that this would be your answer, as I've sorted the factors. Now first of all, I am filling up the gap which is between x and y. I've initialized my current to x, and I keep filling in till the current value reaches to y, and I'm incrementing the value of current by div each time. I'm doing it iterating this loop middle terms plus 1 times, plus 1 because I've included x in this loop as well. After filling the in between elements and x, I'm filling up the y, and while doing so I'm also decrementing n, that is the number of elements in our list. If after placing these many elements still I see that there are still elements which are remaining, and then I'm placing it on the left side of our list. So I use the DQ because in DQ I can push the elements in front as well as at the last. So I use the push front operation here, as I'm pushing or I'm placing the elements on the left side of x. Like at this time I'm placing the elements here if the elements are greater than 0, and I'm moving one by one at a difference of div. I'm going to the left side. So yeah, I'm seeing if current is greater than 0 and still remaining with few elements, I'm pushing it in the front of my DQ and decrementing it. After that, I'm still left with few elements. Then I need to put it on the right side of y at a difference y, the difference div. I'll keep placing them till I'm left with 0 elements. So yep, I've done this part here and I've returned true, as it signifies that this factor or this diff can be used as a difference between adjacent elements. So yep, that's all for this video. I hope you liked it. Then please like it and do subscribe to our channel. See you in the next few videos. Till then, take care. Sayonara.